October 1943, a Messerschmitt design office in Augsburg, Bavaria. Willy Messerschmitt's chief engineer, Woldemar Voight, sits at his drafting table studying intelligence photographs that make absolutely no sense to him. The images show what appears to be a single American factory complex in California, stretching across 213 acres. According to the reconnaissance report attached to the photos, this one facility, Douglas Aircraft's Long Beach plant, produced more combat aircraft in 1942 than all of Germany's Messerschmitt factories combined. Voight does the mathematics 3 times because the numbers seem impossible. The report claims American aviation production reached 47,856 military aircraft in 1942 alone. Germany's entire aircraft industry, mobilized since 1939, produced 15,409 aircraft that same year. The Americans were building planes at more than 3 times Germany's rate, and they'd only been in the war for 12 months. This wasn't propaganda. These were Luftwaffe intelligence assessments based on factory reconnaissance, prisoner interrogations, and captured documents. The conclusion was unavoidable and terrifying. American factories operated on principles German engineers considered theoretically sound but practically impossible. They were mass-producing combat aircraft the same way they mass-produced automobiles, treating fighters and bombers not as precision weapons requiring skilled craftsmanship, but as standardized products flowing from assembly lines at rates that defied everything German aviation doctrine assumed about aircraft manufacturing. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The German aviation industry in 1943 was the product of careful evolution spanning 2 decades. After the Treaty of Versailles banned German military aviation in 1919, aircraft development continued covertly through civilian companies. Messerschmitt, Heinkel, Junkers, and Dornier maintained design expertise under the guise of civilian aircraft production and foreign contracts. When Hitler repudiated Versailles restrictions in 1935 and openly rebuilt the Luftwaffe, these companies possessed experienced design teams and established manufacturing facilities. The German approach to aircraft production emphasized quality over quantity. Each aircraft type represented refined engineering, carefully optimized for specific combat roles. The Messerschmitt Bf 109 fighter, which entered service in 1937, embodied this philosophy. It was fast, well-armed, and capable, built in factories where skilled workers assembled components with precision tooling and careful quality control. Production numbers increased steadily: 640 Bf 109s in 1938, 1,540 in 1939, 3,000 in 1940. These seemed like impressive figures. Germany entered World War II with what appeared to be overwhelming aerial superiority. The Luftwaffe possessed approximately 4,300 combat aircraft in September 1939, facing a combined French and British force of roughly 3,000 aircraft. The German aviation industry had capacity to replace losses and expand production gradually. The strategy assumed wars would be short, decided by superior tactics and initial numerical advantages rather than prolonged industrial attrition. The facilities reflected this thinking. Messerschmitt's main production complex at Regensburg employed approximately 8,000 workers in 1940. The factory produced fighters using traditional manufacturing methods. Skilled metalworkers fabricated airframe components. Experienced welders joined critical structures. Trained mechanics installed engines and systems. Each aircraft spent weeks in production as it moved through various workshops. Quality control inspectors checked work at multiple stages. The result was excellent aircraft, but production was fundamentally limited by skilled labor availability and facility size. German aviation planners understood mass production theory. They'd studied American automotive manufacturing. They knew Ford's River Rouge plant could build vehicles at rates German factories couldn't match. But they considered automobiles fundamentally different from aircraft. Cars operated in 2 dimensions on predictable roads at low speeds with large safety margins. Aircraft operated in 3 dimensions in unpredictable conditions at high speeds, where mechanical failure meant death. This difference, German engineers believed, required different manufacturing approaches. Aircraft demanded precision and quality that mass production couldn't reliably deliver. This assumption shaped every aspect of German aviation industry organization. Factories remained relatively small, specialized facilities. The largest, like Junkers Dessau works, employed perhaps 12,000 workers. Most were considerably smaller. The industry relied on networks of subcontractors providing specialized components. An Mi-109 fighter incorporated parts from dozens of suppliers, each responsible for specific subsystems. Final assembly brought these components together, fitting and adjusting them into functional aircraft. The system worked adequately when Germany controlled the pace of warfare. The campaigns in Poland, Norway, France, and the Balkans were short, allowing time to replace losses between operations. Even the Battle of Britain, though costly, didn't fundamentally challenge German production capacity. The Luftwaffe lost approximately 1,700 aircraft between July and October 1940. German factories replaced them while increasing overall strength. But the invasion of the Soviet Union in June 1941 changed everything. Operation Barbarossa committed the Luftwaffe to sustained combat on a scale unlike anything previously experienced. The Eastern Front consumed aircraft relentlessly, not just from combat losses, but from the brutal operating conditions. Dirt airfields damaged landing gear, extreme cold froze hydraulics and cracked engine blocks. Mud destroyed engines during takeoff. Spare parts shortages grounded aircraft that could have been repaired. By December 1941, when the United States entered the war following Pearl Harbor, German aviation planners faced an uncomfortable reality. They were losing aircraft faster than factories could replace them. Luftwaffe's strength on the Eastern Front, which peaked at approximately 2,700 aircraft in June 1941, had declined to around 2,000 aircraft by year's end despite continuous factory production. The response was to increase production urgently. Factories expanded shifts, subcontractor networks grew. The Reich Ministry of Armaments, reorganized under Albert Speer in February 1942, prioritized aviation production. Results followed. Aircraft production rose from 15,409 in 1942 to 25,277 in 1943, then 39,807 in 1944. These increases seemed impressive until compared to American production in the same period. The United States built 47,856 military aircraft in 1942, 85,898 in 1943, and 96,369 in 1944. America outproduced Germany by margins that made the war's outcome mathematically inevitable. German engineers who understood these figures experienced something close to existential crisis. Everything they knew about aircraft manufacturing suggested such production rates were impossible. You couldn't build precision aircraft like automobiles. The technical requirements were too demanding, the quality control too critical, the skilled labor too specialized. Yet somehow, impossibly, American factories were doing exactly that. The initial German response was denial. The production figures must be exaggerated. Propaganda designed to intimidate. American aircraft must be inferior, quantity achieved by sacrificing quality. The planes must be simple, lacking the sophisticated systems German aircraft incorporated. These rationalizations provided temporary comfort, but they couldn't survive contact with reality. That reality arrived in pieces throughout 1942 and 43. Luftwaffe pilots encountered American aircraft in increasing numbers. First, in North Africa, where P-38 Lightnings and P-40 Warhawks appeared in quantities that surprised German commanders. Then over Europe, where B-17 and B-24 heavy bombers began daylight raids escorted by growing numbers of fighters. The aircraft themselves didn't seem particularly inferior. They were well built, reliable, and present in numbers that German logistics couldn't match. Captured American airmen provided additional intelligence. Interrogations revealed details about American aviation training, maintenance systems, and replacement pipelines. The Americans trained pilots in vast numbers at facilities across the United States. They stockpiled spare parts in quantities German logistics officers considered wasteful. They treated aircraft as expendable assets rather than precious resources. When a bomber was damaged beyond field repair, Americans abandoned it and requisitioned a replacement. Germans would spend weeks recovering and rebuilding the same aircraft. The psychological impact on German aviation personnel intensified as the war progressed. Pilots returning from missions over Germany reported encountering bomber formations of 300, 400, even 500 aircraft. The escorts numbered in the hundreds. Luftwaffe fighters shot down dozens of American bombers, but the formations returned the next day barely diminished. It was like fighting an avalanche. You could deflect individual pieces, but the mass kept coming. German fighter production actually peaked in 1944 at approximately 25,000 fighters of all types. This represented a tremendous achievement by German industry operating under Allied bombing and resource shortages. But American fighter production that same year exceeded 38,000 aircraft. The 8th Air Force alone, operating from England, possessed more combat aircraft than the entire Luftwaffe. The bombing campaign against German aviation industry infrastructure represented a deliberate strategy to exploit America's production advantage. If you could build aircraft faster than your enemy, you could afford to lose them in attacks on enemy production facilities. The mathematics were brutal but simple. If destroying one German factory cost 10 American bombers, but that factory would have produced 50 German fighters over the next year, the trade heavily favored the attacker. American planners understood this perfectly. The combined bomber offensive, coordinated between the U.S. 8th Air Force and Royal Air Force Bomber Command, systematically targeted German aviation production. The ball-bearing plants at Schweinfurt, the Messerschmitt factories at Regensburg, the Wiener Neustadt complex in Austria, all received repeated attention. Each raid cost the Americans dozens of aircraft and hundreds of crew, but American factories replaced losses within weeks, while German facilities remained damaged for months. The Regensburg-Schweinfurt raid on August 17, 1943, illustrated the dynamic perfectly. The 8th Air Force dispatched 376 B-17s to strike Messerschmitt's Regensburg facility and Schweinfurt's ball-bearing plants. Luftwaffe fighters and flak destroyed 60 B-17s and damaged 138 others. American casualties exceeded 600 men killed, wounded, or captured. The losses were catastrophic by any traditional military standard, representing 16% of the attacking force. But the raid significantly damaged Regensburg's production capacity. Messerschmitt's output dropped by approximately 30% for 3 months while facilities were repaired. The Americans lost 60 heavy bombers. They replaced them in less than 3 weeks from the continuous stream of B-17s flowing from Douglas, Boeing, Vega, and Lockheed factories. The 8th Air Force flew another major mission within days. Messerschmitt couldn't recover its production capacity for months. This asymmetry defined the air war over Europe from 1943 onward. German factories couldn't simultaneously replace combat losses, expand production, and recover from bombing damage. American factories could do all three while still increasing monthly output. The gap widened relentlessly until by 1945, the Luftwaffe faced hundreds of Allied aircraft for every German fighter that could reach combat altitude. The transformation of American aviation from minimal peacetime production to overwhelming wartime output happened with speed that still seems impossible. In 1938, the entire American aviation industry produced 1,795 military aircraft. That's less than Germany produced that same year despite Germany's supposedly secret rearmament. American aircraft manufacturing centered on a handful of companies: Boeing, Douglas, Lockheed, Consolidated, North American Aviation, each operating relatively small facilities building aircraft in batches. The change began before Pearl Harbor. President Franklin Roosevelt, watching European developments with growing alarm, concluded that American air power required dramatic expansion. On January 12, 1939, he requested Congress approve funds for 525 new military aircraft. By May 1940, Following the fall of France, his requests escalated dramatically. Roosevelt wanted 50,000 aircraft per year, a figure that seemed absurd when American production had never exceeded 2,000 annually. The automotive industry provided the solution. William Knudsen, former president of General Motors, became director of the Office of Production Management in January 1941. Knudsen understood mass production better than anyone in America. He'd helped create the assembly line techniques that let Ford build Model Ts by the millions. He knew that aircraft were just complex automobiles that flew. If you could build cars in enormous numbers, you could build planes the same way. The Ford Motor Company's Willow Run bomber plant became the template. Construction began in April 1941 on a facility designed to build B-24 Liberator heavy bombers using automotive assembly line techniques. The building ultimately stretched over a mile long, containing 3.5 million square feet under one roof. Ford engineers designed the production flow so that aircraft components entered at one end and completed bombers rolled out the other. The early months were disasters. When production began in September 1942, Willow Run completed exactly one B-24. Workers couldn't find tools. Components arrived in wrong sequences. The assembly line kept stopping because parts didn't fit. By December, they'd built only 56 bombers, nowhere near the ambitious 1-per-hour goal. But Ford engineers systematically solved each problem. They built 7,500 different jigs, custom fixtures that held components in exact positions during assembly. They standardized parts to eliminate variation. They trained workers in specialized tasks rather than expecting generalist skills. By 1944, Willow Run achieved its promise, producing one B-24 every 63 minutes. The plant ultimately built 8,685 Liberators, accounting for nearly half of all B-24s manufactured. The same principles applied across American aviation industry. Douglas Aircraft expanded its Santa Monica facility and built enormous new plants in Long Beach, California, and Tulsa, Oklahoma, and Chicago. The Long Beach plant alone covered 213 acres and employed 42,000 workers at peak production. These weren't traditional aircraft factories. They were automobile plants retooled for aviation. The production numbers validated the approach. Douglas built more than 10,000 C-47 transport aircraft during the war, the military version of the DC-3 airliner. Each aircraft required approximately 100,000 separate parts assembled into a functional transport. Douglas produced them at rates exceeding 30 per day during peak months. The key was treating complexity as an assembly problem rather than a craftsmanship challenge. North American aviation's story was even more dramatic. The company barely existed in 1939. By 1945, they'd built over 42,000 aircraft, including 16,000 AT-6 trainers and over 15,000 P-51 Mustang fighters. The P-51, which entered service in 1943, became arguably the best piston engine fighter of the war. North American built them in Inglewood, California, at rates approaching 500 per month by late 1944. German engineers studying these production facilities through intelligence reports struggled to understand how such output was possible. The answer lay in fundamental differences in manufacturing philosophy. German factories built aircraft. American factories built assembly processes that produced aircraft. The distinction seems subtle but was absolutely crucial. Consider landing gear production. A German factory assigned skilled metalworkers to fabricate landing gear components. Each worker understood the complete assembly and could adapt to variations in raw materials or specifications. This flexibility was valuable for prototype development and small batch production, but it was inherently limited by how many skilled workers you could train and employ. An American factory designed specialized machines that stamped, drilled, and shaped landing gear components automatically. Semi-skilled operators monitored the machines and loaded raw materials. The machines produced identical parts at high speed with minimal variation. Those parts flowed to assembly stations where workers, following standardized procedures and using positioning jigs, assembled landing gear in minutes rather than hours. The process required less skill but generated far higher output per worker. This approach demanded enormous upfront investment in tooling and factory design. Building the jigs, fixtures, stamping presses, and specialized equipment for B-24 production cost Ford approximately $200 million, equivalent to roughly $3.6 billion today. But once operational, the facility produced bombers at costs per unit far below traditional manufacturing. The initial investment was amortized across thousands of aircraft. Germany couldn't make similar investments by 1942. They lacked the capital, the time, and increasingly, the security. Building a massive aircraft factory in 1943 meant creating a target for Allied bombers. The Americans could build factories in Michigan, Kansas, and California, far beyond any possible German attack. German factories sat within range of British and American bombers from 1942 onward. The labor situation further advantaged America. German aviation factories relied heavily on skilled workers, many of whom were drafted into military service as the war expanded. Germany attempted to compensate using forced laborers from occupied territories and concentration camp prisoners. These workers, starving, brutalized, and with every reason to sabotage, produced predictably poor results. Quality control became a nightmare. Aircraft arrived at frontline units with defects ranging from loose fittings to deliberately damaged components. American factories employed millions of workers voluntarily. Women entered aviation plants in unprecedented numbers, comprising up to 40% of workers at some facilities. Rosie the Riveter wasn't merely propaganda. She represented statistical reality. These workers received competitive wages, decent working conditions, and motivation from knowing their work directly supported family members in uniform. Quality control remained high because workers cared about outcomes. The training differential was equally significant. American factories used their standardized processes to train workers in weeks rather than years. A typical riveting course ran 6 weeks. Students practiced on scrap aluminum until they could produce consistent rivets, meeting military specifications, then graduated directly to production lines. The simplified, specialized tasks meant that someone with minimal experience could perform one operation excellently, rather than needing years of apprenticeship to handle all operations adequately. German factories couldn't replicate this approach because their manufacturing methods required broader skills. A German metalworker needed to understand drawings, select appropriate tools, measure precisely, and adapt techniques to specific situations. This took time to learn and couldn't be compressed into 6-week courses. Germany's skilled labor shortage intensified throughout the war, while America's labor pool expanded continuously. The raw material disparity compounded every other advantage. In 1943, the United States produced 85 million tons of steel. Germany produced 34 million tons. American aluminum production reached 920,000 tons versus Germany's 250,000 tons. These weren't marginal differences. They were overwhelming advantages in the fundamental ingredients of aircraft construction. Aircraft consumed aluminum voraciously. A B-17 Flying Fortress required approximately 12,000 pounds of aluminum. A P-51 Mustang needed about 2,000 pounds. When you're building hundreds of aircraft daily, aluminum supply becomes the limiting factor. American bauxite mines, aluminum refineries, and rolling mills operated at capacity throughout the war, always providing enough material for expanding production. Germany faced chronic aluminum shortages from 1943 onward. The situation grew desperate enough that the Reich Ministry issued directives for collecting aluminum from civilian sources. Pots, pans, household items, anything aluminum was confiscated for aircraft production. These measures provided only token amounts. The fundamental problem was that Germany lacked the electrical generating capacity to refine aluminum in quantities modern warfare demanded. Aluminum refining requires enormous electricity. American hydroelectric dams in the Pacific Northwest powered aluminum plants that Germany could never match. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The logistics of aircraft distribution revealed another dimension of American industrial superiority. Building aircraft was only half the challenge. Getting them to combat theaters required a distribution network of staggering complexity. The United States developed systems that treated aircraft delivery like package shipping, systematized and reliable. The Air Transport Command, established in June 1942, operated global air routes ferrying aircraft from American factories to combat zones. The South Atlantic route flew aircraft from Florida to Brazil, across to West Africa, then north to bases in North Africa and Europe. The North Atlantic route went through Newfoundland, Greenland, and Iceland to Britain. The Pacific routes stretched from California through Hawaii, various island chains, and ultimately to bases in Australia, New Guinea, and later the Philippines. Pilots fresh from training flew brand new aircraft on these routes, delivering them directly to combat units. The system moved thousands of aircraft monthly. In October 1944 alone, the Air Transport Command delivered over 3,000 aircraft to overseas theaters. This logistical capacity meant that combat units received replacement aircraft within weeks of requisitioning them. Germany possessed no comparable system. They couldn't fly replacement aircraft to distant theaters because Allied air superiority made such flights suicidal. Aircraft destined for North Africa had to be partially disassembled, shipped by sea, then reassembled at destination. The Mediterranean was increasingly controlled by Allied naval and air forces. Many ships carrying aircraft never arrived. Those that did delivered aircraft weeks or months after units requested them. The Eastern Front presented different but equally severe logistics problems. Aircraft could fly from German factories to forward airfields, but the distances were enormous and the route hazardous. Soviet fighters prowled transit routes. Winter weather grounded flights for days. Navigation over featureless terrain led to aircraft getting lost and running out of fuel. The delivery rate never matched the destruction rate. By mid-1944, German aviation faced an impossible situation. They were producing more aircraft than ever before, but operational strength continued declining. The reason was simple mathematics. If you produce 1,000 fighters monthly but lose 1,200 in combat and operational accidents, you fall behind despite increasing production. Meanwhile, if your enemy produces 3,000 fighters monthly and loses 1,000, they grow stronger. The turning point, the moment when German engineers confronted undeniable evidence of American production superiority, came not from intelligence reports but from captured facilities. As Allied forces advanced across France in late 1944, they overran Luftwaffe airfields and storage depots. What they found shocked even the Americans who thought they understood German desperation. At abandoned airfields near Paris, American intelligence officers discovered rows of German aircraft, Bf-109s and Fw-190s, sitting serviceable but unfueled. The fuel shortage had become so severe that operational aircraft were grounded for lack of gasoline. Pilots were available, ammunition was available, the aircraft were functional, but without fuel, they couldn't fly. Interrogations of captured Luftwaffe ground crew revealed the extent of the crisis. Germany's synthetic fuel production, which provided most aviation gasoline, had been systematically destroyed by Allied bombing from mid-1944 onward. The hydrogenation plants that converted coal to gasoline were precision targets. Destroy the catalyst chambers, and the entire plant became useless until repaired. The Americans and British hit these facilities repeatedly. By September 1944, German aviation fuel production had dropped to 10,000 tons monthly, down from 180,000 tons in March. The Luftwaffe needed approximately 160,000 tons monthly just to maintain current operations. No amount of aircraft production could overcome fuel shortages of this magnitude. Fighters sat on airfields, immobile and useless, while Allied bombers flew overhead. The captured German pilots and engineers processed through interrogation centers told stories that revealed their psychological state. Lieutenant Hermann Buchner, a Bf-109 pilot captured in October 1944, described his last mission to American interrogators. His fighter group had been ordered to intercept a bomber formation over western Germany. They took off with enough fuel for 20 minutes of combat. When they engaged the American bombers, they found themselves facing escort fighters in numbers that made interception impossible. Buchner's account was matter-of-fact and defeated. They shot down 3 bombers before P-51s arrived in overwhelming numbers. His group lost 5 aircraft in the first 3 minutes of the fighter engagement. The survivors, including Buchner, broke off and returned to base, landing with nearly empty tanks. 2 days later, the same airfield was bombed by B-24s. His squadron never received replacement aircraft for the 5 lost because the allocation went to other units deemed higher priority. A week later, Buchner was shot down during another intercept mission and captured. The interrogator noted that Buchner showed no bitterness toward Americans. Instead, he expressed something close to admiration for the logistical system that delivered such overwhelming force. Buchner had been a mechanical engineering student before the war. He understood manufacturing. He told the interrogator that Germany had lost the war in 1942 when America's factories truly mobilized. Everything since then was just working through the inevitable mathematics. This sentiment appeared repeatedly in interrogation reports from late 1944 and early 1945. German aviation personnel, especially those with technical backgrounds, recognized that they'd been defeated by production capacity rather than tactical or technical inferiority. Their aircraft were often superior in individual performance. Their pilots, when experienced, were excellently trained. Their tactics were refined through years of combat. None of it mattered against an enemy who could absorb losses and return stronger the next day. The final collapse of German aviation came in the first months of 1945. Operation Bodenplatte, launched on January 1, 1945, represented the Luftwaffe's last major offensive action. German fighters attacked Allied airfields in Belgium, Holland, and France in a coordinated surprise strike. The Germans destroyed approximately 144 Allied aircraft, mostly on the ground, and damaged 123 others. But the Luftwaffe lost between 214 and 300 aircraft in the operation, depending on which sources you credit. More devastating, they lost approximately 230 pilots killed or captured. These included experienced squadron and group commanders whose tactical knowledge couldn't be replaced. The Germans traded irreplaceable assets for losses the Allies barely noticed. Allied records show that the aircraft destroyed on January 1st were replaced within 72 hours. American depots in England had thousands of fighters and fighter bombers in stock. Replacement aircraft were delivered, pilots were assigned, and squadrons were operational again within days. The Luftwaffe never recovered from Bodenplatte. They'd gambled everything on one attack and lost. By February 1945, Luftwaffe operational strength had collapsed. They could generate perhaps a few hundred sorties daily across all fronts. The Americans and British flew thousands. German pilots described the hopelessness of taking off knowing you were outnumbered 10 or 20 to 1. Many experienced pilots were killed in these final months simply because the odds made survival impossible. The industrial story that defined this outcome was written in American factories operating thousands of miles from combat. The workers who built aircraft in Long Beach, Wichita, Fort Worth, and Tulsa never saw the war directly. But their work, repeated millions of times across shifts and months, created an avalanche of material that buried German resistance. The final accounting reveals the magnitude of disparity. From 1940 to 1945, American factories produced roughly 297,000 military aircraft of all types. Germany produced approximately 119,000 aircraft in the same period. American produced 2.5 times Germany's total output, despite entering the war 2 years later. But total numbers understate the advantage because they don't account for losses. The United States could sustain higher loss rates because replacement pipelines always exceeded attrition. Germany couldn't replace losses, even when production increased, because they were losing aircraft faster than factories could build them. The quality comparison is more nuanced. German aircraft were often superior in specific performance parameters. the Bf-109 at high altitude, the W-190 as a weapons platform, the Me-262 jet fighter in raw speed. These aircraft represented excellent engineering, but they were complex, difficult to maintain, and produced in insufficient numbers. American aircraft prioritized reliability and producibility. The P-47 Thunderbolt was enormous, heavy, and consumed fuel voraciously, but it could absorb tremendous battle damage and bring pilots home. Its radial engine was reliable and easy to maintain. Most importantly, Republic Aviation built 15,683 of them. The P-51 Mustang achieved the ideal combination of performance and producibility. It could escort bombers to Berlin and back, a feat no other fighter could reliably accomplish. It was also relatively simple to build. North American Aviation produced them at rates German factories couldn't match, even for simpler aircraft. The Mustang's Packard-built Merlin engine, licensed from Rolls-Royce, represented another industrial advantage. The Americans could license foreign designs and mass-produce them better than the original manufacturers. German engineers who survived the war and later emigrated to America or worked with American companies expressed consistent themes in their memoirs and interviews. They'd been taught that quality and precision were paramount. American mass production seemed crude by comparison. But the Americans understood something fundamental that German doctrine missed. In industrial warfare, adequate equipment in overwhelming quantity defeats superior equipment in limited numbers. Willy Messerschmitt himself, interrogated after the war, acknowledged this reality. He defended his aircraft designs as excellent for their intended roles, but he admitted that Germany could never have matched American production regardless of design choices. The industrial capacity simply didn't exist. Germany was a regional power attempting to fight continental powers simultaneously. The mathematical outcome was inevitable. The lessons extended beyond aviation. The same dynamic played out in every industrial category. American shipyards built Liberty ships faster than German U-boats could sink them. American tank factories produced Shermans in numbers that overwhelmed qualitatively superior German Panzers. American artillery ammunition production exceeded German consumption rates, even during their most intensive operations. This represented the ultimate validation of democratic capitalism's productive capacity. The Soviet Union proved that authoritarian systems could also generate enormous industrial output through forced mobilization, but the United States demonstrated that voluntary labor, competitive markets, and decentralized innovation could produce even more while maintaining higher living standards. The workers who built aircraft in American factories were paid middle-class wages. They lived in their own homes or adequate housing. They had sufficient food, healthcare, and consumer goods. German workers, even before Allied bombing intensified, faced rationing, long hours, and declining living conditions. Soviet workers existed under even harsher conditions. The Americans proved you could have both prosperity and overwhelming military production simultaneously. The strategic implications reshaped post-war understanding of military power. Industrial capacity became recognized as the foundation of military strength. Nuclear weapons would later complicate this calculus, but the fundamental lesson remained. Nations that can outproduce enemies hold decisive advantages in sustained conflicts. The Korean War validated these lessons again when American industrial mobilization, though slower than World War II, still overwhelmed North Korean and Chinese production. Vietnam complicated the picture because industrial production couldn't solve political and strategic problems, but the capacity remained. The Cold War became partially an industrial competition, with the Soviet Union ultimately unable to match American economic and productive capacity. The German engineers who studied American production in 1943 and 44 were witnessing the future of warfare. Precision and craftsmanship had given way to process engineering and mass production. Individual heroism and tactical brilliance mattered less than logistics and industrial capacity. The romantic view of warfare as a test of national character faced the prosaic reality that wars were won in factories as much as battlefields. The final flights of the Luftwaffe in April 1945 showed pitifully small numbers of aircraft facing thousands of Allied planes. Berlin's sky, once defended by hundreds of fighters, saw perhaps a dozen German aircraft during the final battle. They were swept aside casually by overwhelming force. The workers at Willow Run, Long Beach, and hundreds of other American factories had won a victory as decisive as any achieved by combat units. They'd built an avalanche of aircraft that buried German resistance under sheer material weight. The fact that most of these workers were ordinary Americans, including millions of women who'd never worked in factories before the war, made the achievement even more remarkable. When the war ended in May 1945, American aircraft production began immediate decline. The factories that had built nearly 100,000 aircraft in 1944 produced only 46,000 in 1945, as orders were cancelled. By 1946, production dropped to less than 2,000 aircraft. The massive industrial mobilization demobilized almost as quickly as it had formed. The factories converted back to civilian production or were sold for other uses. Willow Run eventually produced cars again, though never with the same intensity it had built bombers. The workers returned to civilian life, many women leaving industrial work as veterans returned. The extraordinary moment when American factories had produced aircraft in numbers that seemed impossible faded into history, but the legacy remained. The United States emerged from World War II with industrial capacity and engineering expertise that dominated the post-war world. The techniques developed for mass-producing aircraft applied to every industry. The management systems, quality control methods, and training programs perfected during the war became standard practice. The German engineers who'd studied those intelligence photographs in 1943, who'd tried to understand how American factories produced 50,000 aircraft yearly, had witnessed something genuinely revolutionary. Not merely production numbers, but a transformation in how industrial societies organized manufacturing. The assembly line techniques that Henry Ford had pioneered for automobiles had scaled to the most complex weapons systems, proving that with sufficient engineering and organization, almost anything could be mass-produced. That understanding shaped the second half of the 20th century. American industrial dominance, built partially on wartime manufacturing experience, underwrote economic prosperity and military strength for decades. The lesson that production capacity determines military outcomes influenced strategic thinking across the world. Nations that couldn't match American industrial output sought alternative strategies, asymmetric warfare, guerrilla tactics, and eventually nuclear deterrence. But in the specific context of World War II, the story was straightforward. German engineers couldn't believe American factories stamped out 50,000 planes per year because such production defied everything they understood about aircraft manufacturing. They were right that it was extraordinary. They were wrong that it was impossible. The Americans proved that impossible was just a limit waiting to be exceeded through organization, investment, and the productive capacity of a fully mobilized industrial democracy. The final image that captures this story is simple. An American factory worker, perhaps a young woman who'd been working in an aircraft plant for 6 months, pulled the rivet gun trigger one more time on a bomber that would fly over Germany. She didn't know that her work, multiplied by millions of similar actions across thousands of factories, was breaking the will of German engineers thousands of miles away. She was just doing her job, collecting her paycheck, and supporting the war effort. But collectively, she and millions like her were winning the war through sheer productive capacity that Germany simply couldn't match. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.